This is Pre-Calc section 10.5 of the Conic sections, and what this section covers is us being able to identify what type of conic section we have when we look just at an equation. And sometimes the equation will be in standard form and sometimes it will not. But there are certain things we can look at right off the bat. If we have just one variable squared, whether it's x squared or it's y squared, you know you have a parabola. So that's the easiest one to identify. If there is only one variable squared, it is a parabola. The other one that's very easy to identify is a hyperbola, because the hyperbola has a minus between the squared terms, whether it's in this standard form here or if it's in the general form there. There is still a minus between the squared terms. This says 8y squared minus 4x squared. That makes it a hyperbola. So parabola and hyperbola are very easy to look at, are very easy to identify. The circle and the ellipse are similar because they both have a plus between the squared terms. Now, if the a squared equals the c squared, or in other words, there's equal squared coefficients, you know you have a circle. So something like this, 4, 4, those are the same numbers, those are the squared coefficients, that's a circle. And of course you would recognize the circle when it's in standard form. The ellipse in standard form has the plus in between, but it has these numbers in the denominator in the standard form. In the general form, we don't have that, but we have these two coefficients that are in front of the squared terms, and they are different. Now notice up here in this general form up here is this bxy. None of these have the bxy to deal with yet. We'll look at that in a little bit. So what I want to do now is put a list up here and identify what type of conic section we have. So what you could do is stop the video and see if you could identify these on your own, and then stop the video again and look at what the answers are. This has only got one item squared, therefore it has to be a parabola. This we have a plus in between, which says, okay, it's either a circle or it's an ellipse, but because these two denominators are different, it's an ellipse. This is in a standard form. There's a minus in between the x squared and the y squared, therefore it's hyperbola. You look here and you might be fooled into thinking it was an ellipse because it's got the plus and it's also got denominators, but notice the denominators are the same, therefore it's a circle. I know we didn't do circles in pre-calculus, but you did do circles in college algebra, so you should recognize a circle. This has x squared and y squared in the problem, but it's not in any kind of form I recognize. I need to have the x squared and the y squared together on the same side. So if I subtract y squared from both sides, I'm looking at x squared minus y squared equals 64, and there you go, you have your minus, therefore it's a hyperbola. This one has got only y squared, therefore it must be a parabola. I look here, I don't want to have to complete the square, I'm just looking at the squared terms. This says 2x squared plus 2y squared. Since there's a plus in between and those two coefficients are the same, it is a circle. And this also has a plus, 4x squared, plus 16y squared, but those coefficients are different, therefore this represents an ellipse. Now we can use this right here to identify what type of conic section you have if there is no xy term. What I just showed you right here works just fine if there is no xy term. I personally like this better than this, but there is a definite formula way to tell what you have. So remember what a and c are. A and c are the coefficients in front of the squared terms. If a times c equals 0, it's a parabola. If a times c is greater than 0, it's either an ellipse or a circle. And if a times c is less than 0, then what you have is a hyperbola. So what we have to do here is we're just looking at the squared terms, just the squared terms coefficients. This does not matter. If we do 3 times 6, that's 18. 18 is greater than 0. So this tells me it's either an ellipse or a circle. Well, that doesn't help a whole lot. I need to identify which is which. So I've got to fall back on what I taught you in the previous screen, and that is these two coefficients are different, therefore it's the ellipse. Same thing here. Here's my coefficients, 2 times negative 3. 2 times negative 3 is negative 6. Negative 6 is less than 0, and therefore it's a hyperbola. But to me, why do all that work? I can see right there, there's a negative between or minus between those terms, therefore I know it's a hyperbola. This right here, following their rules, we've got a, which doesn't exist. There is no x squared, so that's 0. times 1 is 0, therefore it's a parabola, but it sure is easy just to look at this and identify all I have is 1 term squared, therefore it's a parabola. Now these rules are used when you do have an xy in the term. So this says we've got a parabola if b squared minus 4ac equals 0. If b squared minus 4ac is less than 0, then we have an ellipse or a circle. And the hyperbola if b squared minus 4ac is greater than 0. You might recognize the b squared minus 4ac being part of the quadratic formula. So I need my a, my b, and my c. That's these coefficients right here. So let's make a list here. A is 8, b is negative 12, and c is 17. The rest of these coefficients do not matter to us. So we'll do b squared, and I would suggest you put the b in parentheses squared if b is negative. And then minus 4 times a, which is 8, times c, which is 17. The reason I want to put this in parentheses is that if you type this into your graphing calculator without parentheses, it's doing 12 squared and then putting a negative in front of it. So to be sure you get the right sign when you type all this in your calculator, be sure when you are raising a negative to a power, you put it in parentheses. So if you do this arithmetic and you can type all that into your calculator directly, this works out to be negative 400, which is less than 0, which according to the rules right here, it is an ellipse or a circle. And a circle is a type of ellipse. The answer we will go with is just ellipse. I cannot go back to my other rules and look at this and say, oh, those coefficients are different, therefore it must be an ellipse. Because of this xy term, things are different. So just say ellipse. The next one, our a is 1, b is 3, and c is negative 2. So b squared, 3 squared. Notice I didn't use parentheses because that's positive, it doesn't matter. Minus 4 times a, which is 1, which is c, which is negative 2. Type that in your calculator, you get 17, which is greater than 0. And according to the chart, if it's greater than 0, it is a hyperbola. The last one here, a is 9, b is 12, and c is 4. So b squared, which is 12 squared, minus 4 times a, which is 9, times c, which is 4, gives me 0. And if it equals 0, then we know we have a parabola. Note, if we had just looked here and here, we might have thought it was some sort of ellipse because of x squared plus y squared is going to give us an ellipse. But because of the xy term, things are different. So this is a parabola. That's why you have to pay attention to the formula. If there is an xy term in the equation, you have to rely on this information to determine what type of conic section it is. If you have equations like we had back here, where there is no xy term, you can go with this set of rules, or you can go with the set of rules we talked about in the first screen about just the basic tendencies about the conic sections.